This is the PS2 ultrasonic transducer. The PS2 velocity transducer generates high signal quality during all loading protocols at stresses appropriate to system and temperatures to 150 degrees C. Each transducer consists of one compressional and two polarized shear wave crystals. The crystal stacks assembled are resonant frequency piezoelectric elements and mounted to a titanium substrate. The measured compressive and shear wave velocities are used to determine elastic moduli of the test specimen. Utilizing a special core holder with a small dead volume and integral pressure transducer, a second configuration is designed for low permeability materials. This uses a complex transient method for permeability analysis, allowing the use of customizable pressure transients as well as a more traditional oscillation and pulse decay. A flow apparatus and acoustic emission for multi-phase fluid flow analysis are based on theoretical methods to quantify steady state and low permeabilities. Acoustic emission sources emit transient elastic waves that propagate through the test specimen and transform into surface waves at the specimen surface. These surface waves cause surface displacement that is converted into an electrical signal by the sensor. There are 8 channel sensors on the surface of the specimen. Acoustic emissions can be detected and located as a result of the initiation and propagation of microcracks at elevated stresses. The location of an acoustic emission source is determined by analyzing the arrival time differences. Acoustic emission events occur not only as the external stress changes, but are also generated by fluid flow, rock-fluid chemical interaction, and phase changes. This is useful to track the real-time processes under study in the specimen. Unlike conventional triaxial equipment, a prismatic specimen can be loaded in one transverse principal stress direction with flat jacks using the vessel wall as a reaction force, while the other lower transverse principal stress direction is pressurized with a confining fluid.
The system has a maximum axial loading of 3,560 kN or 800 kips, capable of testing most rock and hard materials with diameters from 25 mm to 100 mm or 1 inch to 4 inches. This system provides simultaneous measurements of velocity, permeability, stress, and deformation over user-prescribed loading path. This system is supported by an AutoLab software that controls the loading path and temperature profile during each test, stores the data, and processes the results at the conclusion of the experiment. These coupled measurements provide comprehensive data to facilitate the understanding of the time-dependent relationship between physical and mechanical properties, which could not be accomplished with most triaxial equipment.